Now we're going to do some practice problems when it has to do with radians. And radians is kind of a new thing that we've started teaching in geometry. In the past, it has been more of, we've just dealt with degrees. So radians, it's something that we go through and we talk about, but again, it's something that's a little bit newer. And when you get to Algebra 2 and Pre-Cal, you're really going to learn about radians in the unit circle. So that's why we start to touch on that now when it comes to circles. So the first question, if theta equals pi over 2 and r equals 4, solve for the length of the intercepted arc. And if you recall, theta equals s over r. S is the length of our intercepted arc and r is our radius. So I know that theta is pi over 2 and that's going to equal s over 4. So now we're just going to cross multiply and divide. So 4 times pi, we would get 4 pi and that equals 2s. And then we divide by 2 on both sides. So the length of our intercepted arc is 2 pi. Now for question number 2, if our radius is 5 and the intercepted arc, if our radius is 2 and the intercepted arc is 5, what is the measure of the central angle? So again, we're just going to use the theta equals the intercepted arc over the radius. Here, we're just going to plug in our numbers. So we have 5 over 2, so that's 2.5 radians. Now, if we want to convert that to degrees, we would take we multiply by 180 over pi. So if we converted that to degrees, we do 2.5 times 180, and then we would divide that by pi, which would give us approximately 143 degrees. Okay, number 3. At the same central angle theta, if the radius is 6 centimeters, what is the arc length of the intercepted arc? So, we've just got a proportion here. We know that these are the same. We can just set up a proportion. We've got 18 over 12 equals 6 over x. And the reason why we can set up this proportion is because all circles are similar. And since we're dealing with the same dimensions, we're dealing in length for both of them, we can just simply set up a proportion. So when we cross multiply, we get 18x equals 12 times 6, which is going to be 72. We divide both sides by 18. And we get 4. So the length of this arc right here would be 4. Down here it says the measure of a central angle is 120 degrees. The length of the radius is 20 centimeters. So determine the arc length using this formula, and then we're going to use this formula down here. So we're going to use both methods and show that they're both going to be the same. So here we take our given degrees, which is 120 over 360 times 2 pi. My radius is 20. So let's go ahead and stick that in our calculator. Whoops, forgot my parentheses. Times 2 pi 20, and I get 41.9 centimeters. Now I want to determine the arc length using this formula. So we know our angle. We're going to put that into radians. So 120, we need to multiply by pi over 180 to convert that to radians times pi over 180. And we get 2.1 radians. So 2.1 equals s over 20. Now I'm going to multiply 2.1 times 20, and I get 42. So either way that we work this out, we're going to get the same answer. We got 41.9 here. Here we got 42. But if you look, it's not actually 2.1 radians is 2.09, and it's a decimal. So we rounded. We've got a little bit of a rounding error there. But either way, we got the same answer.